In this lesson, we're going to review your grade 10 trigonometry. That means we're looking at Pythagoras, we're looking at the sum angle property, and we're looking at your primary trig ratios, and then the inverse trig ratios as well. So what do I mean by all this? Let's have a quick review here. So when you're looking at a triangle question, you're going to ask yourself various questions, right? The first one, if we're looking at the Pythagorean theorem, we're looking to see if your triangle is a right angle triangle, first of all, because that's the only time we can use it. And if you're given two lengths of a right triangle, and you're looking for the third triangle, then you're for sure going to use it. And just a reminder that that's going to be a squared plus b squared equals c squared. And you're solving for whichever letter is necessary. Remember that c is always your hypotenuse. Now, if you're given two angles in a triangle and want to know the third angle, even if the triangle isn't a right angle, you can use the sum angle property. And we've already used that in some other units. So that just means that all angles in a triangle add up to 180 degrees. If you're given at least one angle, but not the right angle, so one other angle, and at least one side, and you're looking for another side, then you can use your primary trig ratios, and that's sine, cosine, tangent, and you've seen those before. Right? And if you're given the side lengths of a triangle and want to know the related angle, you use the inverse trig ratios. And that's when we're going sine minus 1, cos minus 1, or tan minus 1. Now, we may not have done this in the graphing calculator before. So the first thing I'd like you to do is take out your graphing calculator and click on mode. And you'll see every time you reset your calculator, these are the default settings. So we would like our mode to be in degrees. So right now it's in radians, and there are times when we want our calculator to be in radians, but right now we want it in degrees. So before you do any sort of trig questions, make sure your calculator is in the mode that you want it to be in. Alright, let's go back to the questions. Now, let's have a look at example 1. What we're going to do is we're going to see what we're given, what's unknown, and what tool we need to use. So in example 1, it says find the measure of angle 1. Now we have two tools for finding angle measure. We can either use the inverse trig ratios, or we can use the sum angle formula. Now when I look at these questions, I see that I'm already given two angles. Now if I'm given two angles and I want the third angle, then all we're doing is the sum angle formula. So we know that angle 1 plus 92 degrees plus 30 degrees gives us 180 degrees. So the math that we could do for that is angle 1 is equal to 180 degrees, subtract the other two angles. And if you do that, you'll get that angle 1 is equal to 58 degrees. Go ahead and try numbers 2 and number 3, and come back and check your answers with me. So for number 2, you should have got that angle 1 is 23 degrees, and for question 3, you should get that angle 1 is 47 degrees. Alright, let's take a look at question 4. 4 says solve for A. What am I given here? Well, I see there's a 90-degree angle, so I can probably use trig or Pythagoras. I see that I'm given one side, and I want one side. I don't know what this side is, but I am given this angle. So given one side and one angle, find the other side. That's going to be my primary trig ratios. Now in order to figure out which one I need to use, I need to be able to label my triangle. The easiest side to label is your hypotenuse. And the reason why I say that is because we know it's always directly across from the 90-degree angle. I'm going to label that one first. The rest of the angles are always labeled according to either the angle given or the unknown angle. In our case, that's our 25-degree angle. So across from the 25-degree angle is our opposite side, and beside our 25-degree angle, we call that our adjacent side. Once I have my triangle labeled, I can decide what is useful to me and what is not going to be useful to me. I need to use the hypotenuse because that's a value given. I need to use the opposite because that's what I'm trying to solve for. So the value that's not useful to me is my adjacent, and there actually is no value that's given to me. So the only trig ratio that uses opposite and hypotenuse, if I look up here, is my sine ratio right here. Okay, so my sine ratio gives me sine theta equals opposite over hypotenuse. I'm going to start by writing that out. So sine theta is equal to O over H, just simplifying this. Now I'm going to substitute any given information. Instead of theta, well, theta is our angle, so sine of 25 degrees is equal to my opposite side, which is what I'm solving for, A, over my hypotenuse, which is 34. Now I need to solve for A. So I'm using my algebra skills to isolate A. Multiply both sides by 34 to get rid of the 34. Those cancel out, and I'm left with A is equal to 34 times sine of 25 degrees. Now, because this is a calculator maybe you're not used to using, you need to be able to punch this in. So if I quit this menu, we were in our mode menu, right? I'm going to be typing in 34 times sine, and then they automatically give you the brackets 25. And then you can close the brackets, hit enter, and we get an answer of 14.369 and so on. So we can round this to 1 or 2 decimal places. Usually I'll let you know. It's always safe to do 2 decimal places if you're not sure. And we'll put that in our notes here. So A is equal to 14.3, and was that 6? Rounds up to 7 because 6, 9. So it's 14.37. And we look at our triangle to see if there's any units. In this case, there's no units, so that's our answer there. Okay? If you go back to your calculator, let's say you did this in the reverse order and you went sine 25 times 34. Can you see where that becomes an issue? Right? You're actually putting in the 34 in the brackets with the 25, so it's going to sine all of that, which isn't what you want. If you are going to do that, make sure you close the brackets before you times 34, and then you should get the same answer as we got before. So just be aware. It's nice that you can see everything that you're putting in there as well. All right, let's take a look at number 5. Number 5 says solve for angle B. Well, I'm solving for an angle, so I have 2 tools again for solving for an angle, but I can see I have a 90-degree triangle, or a right triangle, and I'm given 2 sides. So I'm going to use my inverse trig. Again, we're going to label our triangle, label it according to angle B, because that's what I'm solving for. But I'm going to start by labeling my hypotenuse, because that's just the easiest one to label right away. Using angle B directly across from that, that would be my opposite, and beside it would be my adjacent side. So now that I have that triangle labeled, I can decide what's going to be useful to me. Well, hypotenuse isn't useful because it's not something I'm solving for, and there's no information there. So I'm going to cancel that one out, or just cross it out. Opposite and adjacent. Which inverse trig ratio am I using? For opposite and adjacent, that would be inverse tan. Okay, so let's write out that formula. Theta is equal to tan minus 1 opposite over adjacent. Fill in what we know. Well, theta is what I'm solving for. Opposite is 9, adjacent is 12. All right, how do I punch this in my calculator? If you hit second tan, that would give you inverse tan, and then we've got 9 divided by 12. Enter, and it gives us 36.87 degrees. And that's the angle for question 5. Let's take a look at example 6. Example 6 says solve for x. Now I've got another 90-degree triangle where I'm given a side length and I'm given an angle. So I'm going to use trig. Label my triangle. I've got my hypotenuse, my opposite, and my adjacent. I can see hypotenuse isn't useful, so I'm using tan, opposite and adjacent. So tan theta over A. Plug in what I know. I know that my angle is 65 degrees, opposite is 29, adjacent is what I'm solving for. In order to get x by itself, I'm going to do some cross multiplication, and this goes up and this goes down. So I've got that x is equal to 29 divided by tan of 65 degrees. Plugging that in, 29 divided by tan of 65. We get an answer of 13.52. All right. In example 7, we can see there's two triangles. So we're going to use the information from one triangle to solve the other triangle. So what I'm suggesting is go ahead and try this one on your own, and then come back and check and see if you get the same answer that I get. So go ahead and do that. All right, so how did you do this? We've got two triangles, and I have to make some decisions here. This triangle has two unknowns. So that lets me know that I'm going to have to do something with this triangle first. Now looking at this triangle, I've got two side lengths and I've got a 90-degree triangle. So that tells me I need to use Pythagoras to solve for x. So I'm going to write out my a squared plus b squared equals c squared. How do I know which side is which? Well, a and b are my two legs that make my 90-degree triangle. It doesn't matter which one you label a or b, but it does matter that x is labeled your c, because that's always your hypotenuse when you're dealing with Pythagoras. So here I've got 4.2 squared plus 6.8 squared is equal to x squared. 17.64 plus 46.24 is equal to x squared. Add those together and you get 63.88 is equal to x squared. At this point, we're going to square root both sides. Whoops. And the reason for that is that's what we're using to undo the squared. So this squared and the square root cancel each other out. So I'm left with x is equal to 7.99. All right, but all that did was give me this x value. I didn't finish the question yet, but that's good, right? So that's A, B, and C. Now, with the second triangle, I see that it's a 90-degree triangle as well. Now I have two side lengths, and I want to find the third side length. So in fact, I'm using Pythagoras again. So I'll write it again, a squared plus b squared is equal to c squared. And I know my hypotenuse is c, but wait a moment. If this is my hypotenuse that's across from the 90 degrees, then this is no longer c. So that was c for the first triangle, but for the second triangle, that x value is now going to be a or b. So be very careful and be very aware as to how you're labeling your triangle. That's not going to remain c anymore. So I'm going to actually erase my labels here as to not get confused and label these a and b. So a is y squared, b is 7.99 squared, equals c squared, so that's 10.4 squared. So I'm solving for y now. Well, let's evaluate and get 63.84, and here this would be 108.16. Now, to get that y squared by itself, I'm going to have to do some algebra. Get rid of the 63.84 by subtracting from both sides. So I'm left with y squared is equal to 44.32. At this point, we could square root both sides to get rid of the squared. And we'll get our final answer that y is equal to 6.66. All right, so that's Pythagoras. We haven't had a Pythagoras question yet. So that's how we use that. And that was a nice question where we had to solve one to get the other. The last two examples that we're going to work on are word problems. For number 8, it says, how tall is a tower if the angle of depression from its top to a point 75 meters from the base is 62 degrees? Be sure to include a diagram. So there's two pieces that are kind of different here. Well, three. One, we're given this in words, right? Now we've got a word problem. Two, there's some language here, angle of depression, that we got to remember what that means. And then the third part is drawing the diagram. Okay? Alright, so in order to draw the diagram, we need to pick out the important information in our question. Now, they talk about the angle of depression. What is that? That's 62 degrees. We want to know how tall the tower is. That's our unknown. And they're talking about a point 75 meters from the base. Alright, so let's draw this tower. So here's my tower. A point 75 meters from the base or the bottom of the tower. So that's 75 meters. And the angle of depression is going to that point. Now, remember, if this is your eye, right? This is your line of sight. When we're looking up, this angle in here is your angle of inclination. Sometimes we see it elevation. When you're looking down, that is your angle of depression. So that's where we are. We're at the top of the tower looking down. So if I'm looking down, so this is my line of sight, so I'm looking down to that point. So we've made a 90-degree triangle. We want to know how tall the tower is, and that angle of depression is in here at 62 degrees. A lot of students put it in here. That's incorrect. So our angle of depression is in here at 62 degrees. Well, that's kind of useless because it's outside of my triangle. However, we know that that angle, because of our angles unit, is the same as this angle in here, 62 degrees. So we can actually put it inside. If you didn't want to do that, you also could use the idea that these two angles have to add up to 90 degrees, and you can go 90 minus 62, and you can get that this is 28 degrees in here. Okay? Whichever way you want to do it, doesn't matter. You'll get the same answer for the height of the tower. Okay? So if we use this 28 degrees, just for fun, we need to use that angle in order to label our triangle. Because if I'm going to use my trig ratios, I've got an angle, I've got a side length, I need to find the other side length. So this would be my opposite, this would be my hypotenuse, and this would be my adjacent. So hypotenuse isn't useful here. Opposite and adjacent, this is tangent. So tan theta, opposite over adjacent. I'm going to now substitute the information that I have. So instead of theta, I'm going to put in 28 degrees. Instead of opposite, that's 75, and I'm solving for adjacent. Rearrange your equation, and you get that x is equal to 75 over tan of 28 degrees. Punch all of that into your calculator. 75 divided by tan of 28. And you get 141.05. But what does that mean? That means the height of the tower is, 141.05. What is that measured in? Meters. Okay, very important to have your units in there. All right, last example for today's lesson. It says a surveyor standing at the edge of one building notes that an angle of elevation to the top of another building is 23 degrees. So you can see there's that line of sight, and there's your angle of elevation. If the buildings are 200 meters apart at the base, how far is the surveyor from the top of the second building? So what are we looking for in terms of x? Well, we know that in this triangle, that this is 200 meters. We know that this is 90 degrees. So I'm solving for this x. Okay? So according to this triangle, you can label it, you can solve for x. I'm going to leave this one for you. So go ahead and try it, and then come back and check with my answer. Alright, after doing this, you should see that the surveyor is 217.3 meters away from the top of the second building. Thanks for joining me in today's lesson.